focusing on just half of our notes, not even half, a little less than half. So goal 5.2 is on adding and subtracting rational expressions. You can probably guess by the fact that we're spending 3 days on it that it's a little bit more challenging than what we just finished in goal 5.1. Okay? In fact, what we did in goal 5.1 still plays a huge part in this because it becomes problems like that, or can become problems like goal 5.1. There is a definite order to what you need to do with these questions. The order is important because if you do it out of order, then you can't get to the right answer. Okay? So, first thing we're going to do is to write our fractions, because what we're going to do today is just like denominators. Everything's going to have the same denominator. When you get to unlike denominators, that's where it gets a lot more complicated. So today, we're talking just about like denominators. And this set of rules, or set of steps, okay, in this order is what we're going to follow every question. So step 1, we're going to write it as a single fraction. That's a big deal, okay? Because once you do that, it starts turning into, slowly, what we did on that assessment we just took, okay? So you're going to write it as a single fraction. Then you're going to add and subtract, if you can. And then you're going to factor, if you can. And then you're going to reduce, if you can. So steps 2 and 3 and 4 don't always happen, okay? So sometimes you get all 3, sometimes you get 2 or 3, sometimes 1 or 3. So they don't always happen, but you need to think those 3 steps. Okay, so step 1, I can never finish this out. There we go. Step 1 is to write this as a single fraction, which just means the denominators are alike, so that comes over as the common denominator. And then 12 minus 3. So that's an equivalent statement, equivalent fraction. So you can take 2 fractions with the same denominator, write them as 1 fraction. And then we're going to go in order with those 3 steps. We're going to add and subtract if we can. And we can. I can take 12 minus 3. That's 9. We're going to factor if we can. We cannot factor. There's no addition or subtraction signs there to allow us to factor. And then we're going to reduce if we can. And we can. I can reduce the 9 and 3. 3 goes into itself once. 3 goes into 9 3 times. And I'm left with 3 over x or 3 over 1x either way. Once I get it written, after I do my addition, subtraction, what we're learning in this section, in goal 5.2, once you do your addition, subtraction, it kind of becomes your 5.1. That's where it becomes 5.1. Okay, some of them are more simple, as you're going to see. Some of them are more challenging. Okay, second question. Step 1, write it as a single fraction. So 7 is my LCD. 18xy minus 11xy comes over. And then we have 3 separate, distinctly different steps. Not all of them happen necessarily. We add and subtract. Can I add and subtract 18xy minus 11xy? Yes. 18 minus 11 is 7. Can I factor? Cannot. There's no addition or subtraction signs, so you can't factor things without those. And then can I reduce? Yeah. I can cancel out my 7s. And I'm left with xy. Okay, next question. My denominator, x plus 3. They're going to be the same for today's lesson. So, writing it as a single fraction, my numerator comes over, 5x comes over, plus 15 comes over. So I'm writing it as a single fraction. Then I go through my 3 steps. Add and subtract. I can't add 5x plus 15 because one has an x and one doesn't. So I can't add. Factor if I can. That I can do. I can take out a 5. So once I've done my adding and subtracting, which I couldn't do on this one though, then it becomes like our assessment we just took today. Factor if you can. So I can take out my common factor of 5. Reduce or cancel if you can. And I can because I have like groups. X plus 3. And I'm left with just 5. Okay, next one. Denominator is the same, x squared minus 9. So 2x minus 18 comes over. Now here's the trick. This is subtraction. It is subtracting all of the second fraction. So that means that that minus goes to everything. And if it's helpful to you, put that in parentheses like I did. So minus to a positive x makes it minus x. And then minus to a positive 5 makes it minus 5. So now I'm going to add or subtract, factor if I can, reduce if I can. 3 steps in order. So 2x minus 1x is 1x. Negative 18 minus 5 is a minus 23. My denominator can factor. It's a difference of squares. X times x, 3 times 3, plus and minus. And then can I reduce anything? I cannot. That group that's in the numerator does not look like the groups that are in the denominator. So this is as far as I can go. So that one I added and subtracted, but I couldn't factor and I couldn't reduce. I don't think I've hit one where I've done all 3 of them. Have I? Nope, not yet. Okay, now remember I said today we're doing only like denominators. So you might be looking at this one and going, well, those aren't alike. But you said we were doing just like denominators. But remember, these are inverses. So we do not want to treat inverses as different denominators, even though they are. So we're going to make them alike, because we can do that only with inverses. So I like x minus 2 better than 2 minus x. I like the way that looks better. So I'm going to change this one. But I can't just change it because I want to. I got to pull out that negative. So when I pull out that negative, what do you think is going to happen there in that middle? Yeah, perfect. It's going to become a positive because it was a minus. You took out a negative, which is going to change it to a plus. So anytime that you are changing an inverse, it's going to change that operation. If it had been an addition, it would have become a subtraction. So now this just becomes a big plus sign. Very good. So if you have inverses, make them the same. Okay, so x minus 2 is now my denominator. Bring my numerators over. 4x minus 3. We don't have to worry about any sign changes because it is addition. So plus 3x minus 11. So now we think 3 steps. Once it's written as a single fraction, you gotta think 3. Add, subtract. Yes, I can do that. 4x plus 3x is 7x. Minus 3 minus 11 is minus 14. Factor, if you can, and I can. I can take out a common factor of a 7. And I'm left with x minus 2. So now again, now we're back to goal 5-1 when we start this part. And then I reduce if I can, and I can. My x minus 2's cancel completely. And I'm left with just 7. Okay, I'm going to go back over a couple things here. Actually, I'm going to go through the whole thing kind of just more quickly. Inverse denominators, don't treat them differently. Let's make them alike. When you make them alike, it's going to change this operation. So when I go to write it as my single fraction, my numerators come over with no sign change. Once I write it as a single fraction, 3 steps. Add or subtract, that's here. Once you add and subtract, then it becomes a question like goal 5-1. Factor if I can, I could, and then reduce if I can, I can. Okay? Okay, we have another inverse one.